Welcome to the Explainer. Today, we are diving deep into Git. We're going to see how this one tool can take the absolute chaos of managing a project and turn it into a symphony of collaboration. Let's get into it.
So here's what we've got lined up. We're starting with the chaos we all know, even working alone. Then we'll get into the magic of pointers, Git's secret weapon. We'll see that in a real-world hotfix situation, and then tackle what happens when universes collide, merge conflicts. After that, we'll cover the all-important safety net for undoing mistakes, before finally putting it all together to go from a solo act to a full team symphony.
All right, first up, from chaos to clarity. Look, a lot of people think version control is just for big teams at big companies. But the truth is, Git starts by solving a problem that every single one of us has, even when we're the only person working on a project.
Oh yeah, you know this screen. We have all been there, staring at a folder that just looks like a total mess. You've got report_final, report_final_v2, and my personal favorite, report_final, I swear this is it, JS. You're too scared to delete anything, right? Because what if that one perfect line of code you wrote at 2 a.m. is in one of those old files? You just have no idea which one is the real one. This whole way of working isn't just confusing, it's a disaster waiting to happen.
A lot of us try to solve this with the shared folder, but that's playing with fire. It's what we call a last save wins game. You and a colleague open the same file. You both make brilliant changes, but whoever hits save last, well, they completely wipe out the other person's work. Gone. Forever. And you might not even notice for days. A version control system, or VCS, is built to stop that nightmare. It's a structured system that tracks every single change, who made it, and when, so you can all work together without stepping on each other's toes.
Now, this is a really big deal. The old way of doing things was centralized. You had one big server in an office somewhere that held the one true copy. Everything you did had to talk to that server. Server's down, you're not working. On a plane with no Wi-Fi, sorry, you're blocked. But Git is distributed, and that is the absolute game changer. It means you and every other developer on your team have a full, complete copy of the entire project history on your own laptop. You can work, make commits, and experiment all while you're completely offline. And since it's all on your machine, it is ridiculously fast.
Okay, so to really get Git, you have to understand these 3 steps. Think of it like a trip to the grocery store. First, you've got your working directory. That's the whole store. All the aisles, everything you could possibly buy. These are just the files on your computer. Next up is the staging area. This is your shopping cart. You don't just dump the entire store into your cart, right? No, you carefully pick the things you want. Maybe you change 3 files, but only one is actually finished. You stage just that one file, putting it in your cart. It gives you total control. Finally, the repository. That's the checkout. When you commit, you are saving a permanent snapshot of whatever is in your cart, and only what's in your cart, into the project's history.
So let's get to the really cool part, the power of pointers. This is the heart of Git's genius. And if you've always thought that creating different versions of your project meant making huge, clunky copies of all your files, well, you're not alone. But Git's got a magic trick that is so much smarter, and it's what lets us work in these wild parallel universes.
This right here, this is the one idea that changes everything. A branch is just a pointer. Most people think creating a branch means Git has to copy your entire project. I mean, if you had a huge project, that would take forever, right? It'd eat up all your disk space. But that's not what happens at all. A branch is basically just a tiny text file with a label on it that points to a specific moment in your project's history. That's it. It's why creating a branch in Git is instant. It costs almost nothing.
To get how these pointers work, you have to see your project's history like Git does. It's not a straight line, it's a graph. Don't let the fancy name directed acyclic graph scare you. All it really means is that it's like a family tree for your code. Every commit is a snapshot, and each one knows who its parent was, all the way back to the beginning. It's just a linked history of every decision you've ever made.
So what's a branch, like master or main? It's just a friendly, movable label. A little sticky note that points to one of those commits in your family tree. It's not a big folder of files, it's just a bookmark that says, "This is my current spot."
And check this out. Let's say you want to start a new feature. You type one command to create a new branch called feature. What does Git do? Does it copy all your files? Nope. It just creates a second sticky note, calls it feature, and sticks it on the exact same commit as master. That's the entire operation. It's brilliant, and it's why branching is so fast.
Okay, now the fun part. You start coding on your new feature, and you make a commit. What happens?
Only your feature sticky note moves forward to the new commit. The master sticky note stays right where it was, completely safe and sound, totally unaware of your new work. Bam! You've just created a parallel universe, a safe little sandbox where you can build things, break things, and experiment, all without any risk of messing up the main stable version of your project. This is isolation, and it is everything.
So if you've got all these parallel universes, how does Git know which one you're actually in? Well, it has one more special pointer, called head. The easiest way to think about head is like the "You Are Here" star on a mall map. It's not pointing to a store, it's pointing to where you are. So head points to the branch you're currently working on. When you switch branches, all Git does is move the head pointer. That's how it knows which universe's files to show you. All right, theory's great, but let's put this to the test with the hotfix scenario. This is a super common, often stressful, real-world situation that shows exactly why this whole branching thing is so powerful. We're about to see how these isolated universes let us handle emergencies without breaking a sweat.
So picture this. You're deep in the zone, coding some big new feature. Your code is a mess, half-finished, maybe it doesn't even run right now. And then, bam, you get an urgent alert. The live website is broken. It needs to be fixed now. Without Git, this is pure panic. But with Git, it's calm. You don't even touch your messy feature branch. You just switch over to your stable master branch, create a new hotfix branch, and now you're in a perfectly clean environment based on the live code. You fix the bug, you merge it, you deploy it. And then, here's the magic. With one command, you switch back to your feature branch, and all your messy, half-done work is sitting there exactly as you left it, completely untouched. That is the power of isolation.
Now, when you merge that hotfix, something simple happened. Because the master branch hadn't changed at all while you were working, the history was just a straight line. So Git could do what's called a fast-forward merge. It's the simplest kind. It doesn't have to think. It just takes the master pointer and slides it forward to where your hotfix pointer is. No new commits are made, it's clean, it's simple, and your history stays in a nice straight line. But what about when things have diverged? You know, the more common case. Maybe while you were working on your big feature, someone else merged something into master. Now you can't just fast forward. The timelines have split. So Git does something smarter, a three-way merge. It looks at three things: your branch, the other branch, and the spot where they originally split apart. Using those 3 points of reference, it weaves the two histories back together and creates a special new merge commit. And what's cool is that this new commit actually has two parents, one from each branch, tying those parallel universes back into one.
And that, of course, brings us to the big one, when universes collide. Look, Git's three-way merge is amazing. It can combine changes from tons of files automatically, but it's not a mind reader. So what happens when it looks at two branches and sees that you and your teammate both changed the exact same line of the same file? Well, that's where the automation has to stop and ask a human for help.
Yeah, the dreaded merge conflict. For anyone new to Git, this is probably the most terrifying moment. Your screen fills up with scary-looking text, and you feel like you've just broken everything. But I want you to take a deep breath, because the single most important thing you can learn today is to reframe what's happening. A merge conflict is not an error. You did not fail. This is the new mindset. Merge conflicts are not errors. They're conversations. Think about it. Git just successfully merged maybe 99% of your changes automatically. It's handled everything it can. And now it's politely pausing, turning to you and saying, hey, I need your help with one last thing. You changed this line to say, welcome, but your teammate changed it to say, hello. I can't guess which one is right. Can you, the smart human, please tell me what the final version should be? It's not a failure. It's a request for your intelligence.
And here's how that conversation starts. Git literally pauses the merge process, and then it opens up the file and adds these special markers right into your code. It's not trying to be confusing, it's being incredibly helpful. It's putting a big spotlight on the exact point of disagreement and showing you both versions side by side so you can make an informed decision.
And these are the markers it uses. It's pretty simple, really. Everything between head and the equal signs is your version of the code. Everything between the equal signs and the other marker is the version from the other branch. Your only job is to play editor. You look at both, decide what the final code should be. Maybe it's one, maybe it's the other, maybe it's a combination of both, and then you just delete all those markers.
And that's it. It's a simple 4-step dance. 1. See which files have conflicts. 2. Open them up and find the markers. 3. Be the editor. Make the code right and delete the markers. And 4. Tell Git the conversation's over by staging that file and finishing the commit.
It might feel scary the first time, but it's a totally manageable process where you are always in control. Okay, on to our safety net. We've talked a lot about moving forward, but let's be real. Sometimes we need to go backward. We all make mistakes. What happens when you merge something and then realize, oh no, that was a terrible idea? Well, Git has a powerful safety net for that too.
Now this is super important. There are two very different ways to undo things. On the left, you have Git Revert. This is the safe way to undo something that's already been shared with your team. It doesn't delete the bad commit, instead it creates a new commit that perfectly undoes the changes from the bad one. It's like a new entry in an accounting book that corrects a mistake. The history is preserved and honest. Now on the right, that's Git Checkout. That's the destructive undo. It's for throwing away local work you haven't committed yet. It basically says, forget everything I just did in this file and give me the old version back. And those changes are gone. Poof, forever. So remember, Revert is for shared history, Checkout is for trashing local mistakes.
Okay, last section, from Solo to Symphony. We've been deep in the weeds on our own computers, right? Talking about branches and merges. Now it's time to zoom out and see how all these little skills combine to let an entire team work together without driving each other completely crazy.
This right here, this is the whole point. This is why we bother with all this. The whole system is built on these ideas. We get isolation because branches are cheap, parallel universes. We get stability because the main branch is always protected and ready to go. We have a safety net because Revert lets us fix mistakes without lying about our history. We get clarity because we've learned to treat conflicts as just a conversation. And all of this is usually wrapped up in a process like a pull request, which is just a formal way to have that code conversation and ensure quality. It's how you get the symphony.
And at the end of the day, that's what it's all about. A team is a process of give and take. Git is more than just a tool for code. It's a social tool. It provides the rules of engagement, the shared language for that process of giving and taking. It's the conductor stand that lets a dozen different musicians, all playing their own part, create one beautiful, cohesive piece of music.
So as we wrap up, I'll just leave you with this final thought. We've seen how Git takes chaos and brings it into order using these really elegant ideas, right? Using lightweight pointers, creating safe spaces to work, and turning scary errors into simple conversations. So my question to you is, what other chaotic parts of your workflow, maybe even outside of code, could use that same kind of structured thinking? Thanks so much for joining me on this explainer.